All right, so the last video cut me off. Okay, so altogether, all of these sets of numbers comprise real numbers. Okay, and the real numbers are that R symbol. Okay, so when we start talking about imaginary numbers obviously aren't real, so they don't fit into this category. Okay, so now we want to talk about how can real numbers and equations, okay, how can we use all of our numbers? Nope, I don't like that. Okay, so now we've got all of these equations, okay, and I'm going to write these on the whiteboard in just a second, but I want to answer these questions here. Okay, so just to kind of give you an example, the first one. So suppose that the only numbers that you may use to evaluate the given equations are the natural numbers. Which equations could you solve? Okay, so we're going to go through and we're going to solve all of these equations and then think about what sets of numbers do those answers belong to. Okay, so here's equation A. Equation A is 3x equals 9. Okay, so if we were to solve this for x, obviously we would divide both sides by 3, and x would equal 3. Okay, so I want to know, is 3 a natural number? Could I use the set of natural numbers as the answers for that problem? And the answer is yes. Okay, 3 is a natural number. 3 is also a whole number. 3 is also an integer. 3 is also a rational number, and 3 is also a real number. So this answer belongs to all of those sets of numbers. Okay, if I solve equation B, which is x plus 1 equals 5, okay, and we solve this for x, obviously we would subtract 1 from both sides, x equals 4, and then 4 would belong to all of those sets of numbers as well, because 4 is natural, it is a counting number, it is a whole number, it is an integer, it is a rational number, I can write it as a fraction, and it is real. Okay, equation C is 8x equals 4. Okay, so if I were to solve this for x, we divide by the 8 because that's the number in front of the x. 4 over 8 reduces to 1/2. So now, is 1/2 natural? No, it is not. Is 1/2 whole? No, it is not. Is 1/2 an integer? No, because an integer is a positive and negative whole number. Okay, is 1/2 rational? Yes, because it is a fraction. And is it real? Yes. So here, this answer only belongs to those two sets of numbers. Okay, equation D is x squared equals 2. Let me move my camera down here. Okay, so when we have an x squared term, we know that we need to take the square root of both sides in order to solve that. So x is going to equal positive and negative minus root 2. Now, the square root of 2 is not natural because we can't count with it. It's not whole. It's not an integer. It's not a fraction, and it's not real. Okay, it's not rational. This one is irrational. So this would be J. So the only set of numbers that this answer would belong to would be the irrational numbers. Okay, a couple more. So F, equation F, x squared equals 4. Okay, so again, we would take the square root of both sides, and x would equal positive and negative root 2. Okay, so my answers here, positive 2 belongs to the naturals, but negative does not. Okay, so I wouldn't use the naturals, and negative numbers are not whole, so the smallest number set that these would belong to would be the integers, positive and negative whole numbers. And then the rationals, because I can write both of those as fractions, and then those are real numbers, so those would be the sets of numbers that my answers would belong to. Okay, last one, equation G. If I have x plus 6 equals 6, and I try to solve for x, we're going to subtract 6 from both sides. X equals 0. So 0 is not a natural number, but 0 is a whole number, so that would be the smallest set. And then 0 is an integer. 0 can be written as a fraction, 0 over 1, and 0 is real. So those would be my answers for that one. Okay, so I'm going to put a document up for your homework for this, and you need to answer the questions and then submit your work via Google Classroom, okay, please, with a picture. Please be honest about your work. Okay, and if you have questions, you can contact me. But this is a pretty straightforward assignment. Okay, so sets of numbers, we got to know which ones are in each set and where they belong, and be able to classify a number into a set.